This lecture is about the Middle Ages in Europe, science in medieval Europe, which was considered to be before as the so-called Dark Ages. So nothing dark about the Middle Ages, science in medieval Europe. Now, people have thought of the Middle Ages as dark. Okay? This is the period between the fall of the Roman Empire and the start of the early modern world in the early 15th century. So why was it called dark at that time? Why did people call it the Dark Ages? It's because people thought that there was no culture and scientific advancement after the fall of the Roman Empire in the year 479 of the Common Era. Now, so our questions are, okay, was there really no culture and scientific advancement at that time? Now, we know that when the Roman Empire fragmented and several kingdoms took over the rule of what was part of the empire, the only what we call transnational, or we can call it transnational now, okay, organization that survived, that was the Roman Catholic Church, which took on a lot of the governance structures and functions of the Roman Empire. Also, during this period, Islam became a dominant religion. It started to spread from Arabia, and the Prophet Muhammad preached his faith based on the revelations that he received from the angel, and which is now written in the Quran. Okay? And that was around in the year 619 of the Common Era. And so, what was the role of Islam in the development of modern science in Europe? Now, another question is, was the rise of modern science subversive? What we mean by subversive is that science challenged certain cultural and religious norms of the time. And I think you have seen this picture before, the School of Athens by Raphael, which is in the Vatican to this day, showing that the philosophers are on one plane, and so the whole idea of education and the intellectual achievement of the West was really to more or less be democratic and equalize the sectors of society. Now, the Needham question. Okay, this was proposed by the biochemist Joseph Needham in the early 1950s. Now, Joseph Needham, who lived to about 95 years, he was born in 1900 and died in 1995, started out as a biochemist, then decided to have a career shift and do research on the history of science, especially in China. Now, one of the questions that Joseph Needham asked is, why did modern science develop only in Europe and advance after Galileo? Why did modern science not develop in other cultures, such as in China or in India, or with the Aztecs in Mexico, or the Mayans in what is now Guatemala, or in Peru, where the Incas established their civilization? So this is the famous Needham question. Why did science develop in Europe and not in those other cultures? Now, the important thing to remember here is modern science, as we know about it, is really the mathematization of hypotheses about nature, with all of its implications for advanced technology. This only happened in Europe. Remember the whole idea that a scientific theory would have to be abstracted or expressed in a mathematical form. That only happened in Europe, not in other cultures. So let's keep that question in mind. Now, the important fact is all civilizations have science and technology. They have their own way of systematizing what they see, okay, what they observe from nature. And that's the basis of technological innovation. For example, China was one of the first civilizations to develop very advanced technologies. For instance, the Chinese were the first ones to invent a blast furnace to come up with a way of making better steel. Okay? This technology was first used in Europe at the end of the Middle Ages, but the Chinese were using it about 600 years before. The Chinese were the first one to come up with gunpowder. They're the first ones to come up with the idea of paper money, with printing. And if we go back in time to the Romans, okay, the Romans were using chariots, okay, as military vehicles. The Chinese were using it too, but it was only the Chinese that developed what we call now as the suspension system. Okay, like our cars have suspension systems, so our ride will not be very jarring. No? But the Chinese had developed the technology which the Romans really did not. Okay, so we can say that China was more advanced at that time with regards to many technological applications as compared to the Romans in Europe. But the important thing is, science, as we know it today, developed in Europe. So, Needham was asking another corollary question. Why didn't China develop a science comparable to that in the West? Has this something to do with the religion of Europe and China? And what is the concept of the divine in Europe and in China? Now, it's important to remember that 2 centuries before the fall of the Roman Empire, the Emperor of Rome, Constantine, adopted Christianity as the state religion because at that time most of the citizens were already being converted to Christianity. Now, Christianity as a religion emphasizes that God became man. In other words, the God of the Christians, which is Jesus Christ, became a real human being. That human being actually is a fact because the person of Jesus Christ actually really existed. It's not only the religious writings like the Bible and the Gospels that really attest to that, but even secular histories written by the Romans and also by the Jews attest to the fact that there was a person named Jesus. Now, if your God became a man, therefore your God has the powers of reason, and perhaps the Christians probably were asking, how did Jesus Christ create the universe? Remember, their belief is the universe was created through Jesus Christ, and perhaps you can find out how Christ did it. Remember, he was a man, by doing some investigations and research. Now, according to Joseph Needham, it was not that there was no order in nature for the Chinese, but rather it was not an order ordained by a rational personal being, and hence there was no conviction that rational personal beings would be able to spell out in their lesser earthly languages, and by that he meant mathematics, the divine code of laws which he had decreed aforetime. So, the Christians believe that their God, because their God became a man, was a rational personal being. Okay. Now, what about in other cultures? Did they have this concept of the divine? The divine is a rational personal being. Like in China, did the Greeks believe their gods are rational? Or did the Romans believe their gods were rational? Or do the gods in India, the Indian people, the Hindus, did they believe that their gods were rational? It was only in Europe with that idea that God became man that there was this assumption that God was rational. So what does that got to do with the development of science in Europe? But before I get into that, perhaps we can look at magic, because magic was a worldview of the more or less primitive religions. Magic is essentially how we understand the powers of nature and how it affects our emotional and physical lives. And this is usually in the realm of myth. Okay? And we believe that these powers correspond to our own well-being. And the explanations for that is beyond nature. Okay, so all cultures have a tradition of magical ideas, no? But science is actually about ending this whole idea of magic because we were going to find out the processes and ways by which nature works, and these processes are quantifiable, observable. As we know, it's empirical. Therefore, it's not magical. Now, as I said, Islam arose in Arabia in around the 6th century. Okay? And Islam is a religion that frowns upon magic and superstition. Islamic culture preserved the Greek and Roman science and mathematics. Okay? And the reason why that is so, because the Prophet of Islam, the Prophet Muhammad, told his people that the ink of the scholar is more sacred than the blood of the martyr. So it only means that at the start of Islam as a religion, there was already a premium on acquiring and generating knowledge and understanding knowledge. And that is not surprising because Islam is a religion based on a book, the Quran. The holy scriptures of Islam is the Quran. Now, it's beyond the course of our STS class to really look in more detail in the history of Islam. However, we know that in the year 610 of the Common Era, the Prophet Muhammad receives revelation, which is written in the Quran. And the Prophet, from 610 to 622, began to preach in Mecca, but a lot of people really did not believe him at the start. And so he went to Medina in Arabia in 622 of the Common Era. And there was a war between the Meccans and the Medina people, and Mecca surrenders and so converted to the religion of the Prophet. Now, the Prophet died in the year 632, and from then on, Muslim armies spread throughout North Africa and Asia, okay, even up to India and also up to what is now Spain and Portugal. So these places became Muslim countries. So that's how fast Islam spread in this part of the world. Within a century, Spain was already a Muslim territory. However, Charles Martel defeated the Umayyad army, this is the Arab army or Muslims, at Tours in France in October 732. This is a major event in the history of Europe because it stopped the spread of Islam into Europe. And that's the reason why the religious geography of Europe and the Middle East is quite distinct. The Middle East is largely Muslim, while Western Europe is historically Christian. Now, we'll get to that later because even if Europe were Christian and the rest of the Middle East was Muslim, or it still is Muslim, it did not prevent the exchange of knowledge, scientific and mathematical knowledge, between the two cultures. Now, as we said, the Muslims preserved a lot of the Greek and Roman knowledge by translating the scholarly works in art and literature and science and mathematics from ancient Greece and Rome into Arabic. And so the Muslims were the first ones to come up with accurate anatomical descriptions of the eye, geometric designs, the geography of the round earth. Now, it is not allowed in Islam to depict the human form in art. Therefore, if you go to the mosques, you would find a lot of geometric designs because it's not really allowed to represent human forms. And the geometric designs also represent the Muslim belief in the majesty and omniscience and omnipotence and being merciful of and compassionate of Allah or God. Now, if Christianity, especially in its Roman Catholic expression, is a religion that allowed for the representation of the human figure in nice paintings or pictures, which we call as icons, Islam does not allow that, but it could allow for the depiction of the words of the Quran in the most beautiful way possible, as you can see here. This is a verse from the Quran and represented in a very beautiful calligraphic way, leading one historian to say that if Catholicism was a religion of nice pictures, Islam is a religion of nice words being represented in art. Now, Islam, during its early history, went through an explosion of scholarship, which we call the Golden Age of Science, which happened about the year 750 to 1258 of the Common Era. Now, the Abbasid Caliphates in Iraq, sponsored the translation movement, in which Greek and Roman texts in science, medicine, and philosophy and mathematics were translated to Arabic. Even mathematical writings in the Hindu language and in Sanskrit were translated into Arabic. For instance, the Siddhanta, which first presented the concept of zero, was actually translated into Arabic as Al-Sindhind. Now, translation is not just translating the meaning of words into another language. It also resulted in theoretical and technological developments. Also, Muslim scientists emphasize the importance of getting empirical observations. And so, for example, the Muslims, these are the three very well-known Muslim scientists of this golden age of Islamic scholarship. Jabir al-Hayad, the alchemist, who was because of their emphasis on observation and getting empirical data, laid the foundations that will become modern chemistry. Ibn Musa al-Khwarizmi was a mathematician and physicist, and his surname al-Khwarizmi is the basis for our word algorithm. The word algorithm was actually taken from his name. And Abu Bakr Muhammad ibn Zakaria al-Razi, which the Europeans Latinized as Reis, was the first person to come up with a very scientific way of clinical diagnosis as a doctor. And so, what could be the answers for the Needham question? Now, you may ask, how come in Islam that scientific development and innovation did not really last very long? Unfortunately, and this is a tragedy really, because of the different caliphates in the Arab world started fighting amongst each other, and so that support and tradition on learning started to decline. So by the time of the 11th century, the scholarship of Islamic scholarship was no longer as productive as it was about a century before. So Cairo and Baghdad were no longer centers of scholarship in the way that they were about 2 centuries before. So who took over that function of generating scientific knowledge, and that fell into the Europeans. Now, of course, what are some of the answers to Needham's question? Roman Catholicism provided a unique intellectual environment that allowed science to develop, and I think we already discussed that in our narratives about the university and academic freedom. But there is also one important event that happened during this time, the Protestant Reformation, okay, which happened 500 years later, okay, um, allowed for the development of social and political environment for rapid technological innovation. Now remember that at the beginning of the early modern period, which the Reformation happened around that time in the 1500s, the a huge number of Christians in Europe left the Catholic Church and founded their own Protestant churches. And they emphasized the Bible and its translation. Now, but before we can get into that, so let's just revisit the cathedrals in France, no, and in medieval Europe. Then you can see that how beautiful are these stained glass windows, and the geometric patterns are reminiscent of the geometric designs in mosques. Now, that is not a mere accident because the European engineers and architects borrowed a lot of engineering techniques and the mathematics used to build the buildings from the Muslims. So there was already an exchange between the Muslims in Arabia and in North Africa with the Europeans. So, if you were someone in the 9th century, you were living in the 9th century, and you were in Europe and you were Christian, you are going to probably accept this medieval principle, which everybody then did not really question. Science cannot contradict faith since both reflect the truth about God. And this remains as the official teaching of the Roman Catholic Church to this day. So if you are a Catholic, then you're obliged to accept this. Now, we have about 10 important scholars of this period. Of course, there are more, but we just couldn't list all of them. And all of these people did not really dispute that idea that science cannot contradict the truth of God, no, because it's just looking at two sides of the same coin. Right? Now, let's look at them. Okay, Pope Sylvester the Second, who's a mathematician, then Anselm of Canterbury, a bishop, Albert the Great, a scientist, Thomas Aquinas, a theologian and philosopher, Mondino de Luizzi, a doctor and a layman, William of Ockham, a priest and a physicist, John the 22nd studied alchemy and became a doctor, okay, but he became Pope later on. Father Roger Bacon and Robert Grosseteste, they are scientists, philosophers, and theologians, and Father Richard Wallingford, who was a horologist, and the brothers Thomas Bradwardine and Richard Swineshead, who were called the calculators, but they were really monks. Now, if you take a look at the list, only one man was not a priest. Mondino de Luizzi. No? All of them, 9 of them are priests, and a few of them became saints, and 2 popes on our list. No, because this is at the time when you cannot get a higher education unless you were a man, and most people who got a higher education in the universities were preparing for the priesthood. So it's no surprise that all of 9 of the 10 people on our list were members of the Catholic clergy. So let's take a look at the first one, Sylvester the Second, which we call the mathematical pope. Now, he was known as Cardinal Gerbert de Aurillac. He was elected in 999. But before then, he studied algebra, geometry, arithmetic, physics, and astronomy. And he is considered to be the first person to introduce Arabic numerals in Europe. and probably the first person in European history to do mathematics and think in Arabic numerals, using Arabic numerals in calculations. Now, as we have learned in the previous talk, okay, he was, well, the Moroccans from the Al-Qarawiyyin University believe that he was really one of their students, no, and attended this university. Although the historical evidence isn't really conclusive, no. But what is certain is that Sylvester the Second, before he was ordained as a Catholic priest, he was really sent by his bishop to study mathematics under the Muslims in what is now Catalonia in Spain. At that time, Spain was Islamic territory. It was an Islamic kingdom. In fact, Sylvester the Second also studied in Cordoba, which is one of the major centers of learning in Islamic Spain. So definitely he studied with the Muslims. We are sure of that. And likely his teachers probably came from Al-Qarawiyyin of Fez, the oldest Islamic university. And so, what did he bring back to Christian Europe? Some of the technology he brought back, like the Astrolabe, which was originally invented by the Greeks and innovated on by the Muslim Arabs. This is used to calculate your position at sea, your latitude at sea, and the armillary sphere represents the motions of the planets around the sun, or around, yeah. Now, one thing that Gerbert introduced, he was known as Gerbert before he was made a pope, no? Upon taking on the position of pope, or the office of the papacy, he chose the name Sylvester. So, Gerbert, we can call him that, introduced Arabic numerals to Europe. And what you see here is actually how he wrote his numerals. You can probably recognize 1 and 8 as how we write those numerals today. 2, 3, 4, 6, and 7, you just put them in the right orientation and probably they would look modern. And 9 is quite recognizable as our own 9. And 0, remember, this was the first time that a European wrote the number 0. And the concept of 0 was borrowed from the Muslims, who borrowed it from the Hindus. Now, we'll get to this number system. This is what we call the Hindu-Arabic number system, which is now what we use. But in Europe at that time, it was not only the number system that was being used. There are other number systems that were used. For instance, the Carthusian monks used their own numerals, and this is a logographic way of expressing the decimal place value system. And so they had ways of doing that, no? Like this is 10, okay? 20, you put that line here. 30, put that little line here. 40, 50 is 5 times 10, okay? So putting all these lines, no? And so on. Now, their system is logographic and also represents the decimal place value system. Now, the Carthusians were a cloistered monastic order, but they made a lot of money from raising sheep for wool. Therefore, they needed a counting system to make sure they're able to count their own money. Now, the important thing to remember here is the number systems developed independently. But it was the Hindu-Arabic numeral system that actually superseded all of these counting systems. Now, why is that so? Because it's easier to count with Arabic numerals. Imagine, before the Arabic numerals were introduced to Europe, people were calculating in Roman numerals. And and probably you and me would know, or you and I would know, how difficult it is to do multiplication with Roman numerals. Now, Gerbert or Sylvester the Second introduced the abacus, which is actually based on the decimal place value system. Now remember that the abacus was invented by the Hindus and eventually borrowed by the Chinese and borrowed by the Arabs. And what Gerbert introduced to Europe is the abacus that was used by the Muslims. No, the Chinese abacus is another kind of way to count numbers. No, and so with that, you were able to easily make or compute numbers according to the decimal place value system. Now, imagine if the Hindu-Arabic numerals were not introduced to Europe, then it will be very difficult to do calculations. And if you can do calculations quite easily, then you should be able to, of course, count your money much more efficiently. And this would lead into all sorts of technological innovations. Now, Sylvester the Second also wanted people to read a lot of books. So he wanted the publication of books. So a statement attributed to him is, "Of the making of books, there is no end." And of course, he was a math teacher, so he wrote a lot of college textbooks on mathematics. This is the Geometria, which is a college textbook for geometry, which students used, okay? And of course, he also wanted his priests to be well educated. Popes are expected to be scholars. Okay? Now, of course, your priests are well educated, so they're philosophers. For instance, Anselm of Canterbury, who lived in the century after Sylvester became Pope, came out with the ontological argument for the existence of God. Now the question is, why is this so important in the history of science? No, it's of course it's important in the history of philosophy and history of Christian theology, but why for science? The point is this, no, because Anselm is one of the first people to come up with a concept that God is an idea in the mind. In other words, God is an abstraction. Now, in other religions beforehand, they considered God probably as a being up there in the heavens, God as a spirit. But in this case, Anselm considered God as an idea in the mind. And so, if a being exists as an idea in the mind and in reality is all things being equal, okay, a greater being that exists only as an idea in the mind. Okay, so if God exists only as an idea in the mind, then we can imagine something that is greater than God. Yeah. Any idea that we have in the mind, we can imagine something that is greater than that. Okay, and that's how creative thinking happens, no? Now, if God is an idea, it's an abstraction. Perhaps you can hypothesize or come up with an idea that's greater than God. But Anselm said that we cannot imagine something that is greater than God, for it's a contradiction to suppose that we can imagine a being greater than a possible being that can be imagined. In other words, our human reason cannot imagine anything greater than God. Therefore, God exists. Now, this is quite interesting because if God is an idea, then you can prove the idea of God using methods, philosophical methods. Okay? And that is so important in the development of science because we need to confirm ideas using demonstrable methods. No? Now, the ontological argument is not just the only argument for the existence of God. Okay, Aquinas came out with the first cause argument, but that's beyond the scope of STS, really, to look at the different arguments for God. But the important point here is that God was represented as an idea, okay, an abstract idea, which is open for philosophical and even scientific investigation. Now, Albert the Great is considered to be the patron saint of science, as declared by the Catholic Church. No, but then he was considered to be the Doctor Universalis, or universal doctor, because he wrote 38 volumes of science books and provided a physical basis for meteorology as a science. No, the reason is that he just explained the existence of clouds and the rainbows, not with a mythological or supernatural sense, but with the physics that was known at that time. So meteorology as a science is based on applying the principles and laws of physics, and that's exactly what he did. Well, the physics that he knew at that time. So he's considered to be the father of meteorology as a modern science. And just like any scientist, okay, he said that the foundation statement of science is, it's the task of natural science not to simply accept what we are told, but to inquire about the causes of things. We need to do research and experimentation to find out what is the truth about the natural world. His student is Thomas Aquinas, who is considered to be Dr. Angelicus, or the angelic doctor. He's a theologian and a philosopher. One of the important contributions of Aquinas is to give science a solid philosophical basis, because he defended the concept of objective reality. Now, we know that a table is a table since you can see it and sense it. In science, as we have discussed before, and it's in the Bagot reading, whatever we are observing exists independently of our minds. In other words, we are not making it up in our own minds, no? And so, a table, you can measure a table, you can actually even find out the quality of the wood that was used to build the table, and you'd know that the table has 4 legs, okay? So that may be the characteristics of a table, but of course there are other things that have 4 legs, like your dog or cat, okay? What makes your dog different from a table, okay? You can put categories on the qualities of objects that you observe, as based on the principle of objective reality. Now, according to Aquinas, it is natural to man to attain intellectual truths to objects he can sense, because all of our knowledge originates from the sense. In other words, according to Aquinas, the only way you can know is to sense. Okay, and the only way you can know about nature is to sense about nature. Now, Pope John the 22nd studied alchemy. Now, he is a lesser known pope, really. Although in Catholic theology, he's quite important. But what about science? No? One of his major controversial decisions was to ban fraudulent alchemy. Because at that time, okay, gold was the standard of currency. Okay? You are paid in gold. In other words, no? The church earns its money from the contributions of people attending the Mass by paying them with gold coins. Now, this was at the time when the medieval economy was starting to advance. And so many people were already working on industries, okay, that would provide us the basis for modern industries much, much later. And so just like today, or at any time in history, there are people who fake money. So the alchemists were accused of producing fake gold. Now, this is the important point here. Alchemy was a rather secretive profession. Maybe if you call it a profession. Because the alchemists claim that they can transmute the base metals, usually the cheap metals like lead, into gold. And they're supposed to have secret methods to do that. No? But of course, we know now that you just cannot transmute lead into gold using standard chemical techniques. No, yeah, you can't do that. No, and so what happened was they were actually manufacturing all sorts of fake things, no, fake money and fake gold or whatever. And so, of course, what happened was the Pope decreed that all of their methods should be made known public in writing, so for others to replicate their methods. And so a lot of the alchemists who were faking money were caught and sent to jail. Now, by requiring all of these methods to be out in the open, to be scrutinized by people, is at the birth of modern science, because science requires that our methods are made public and made known, and anybody could read about it and do the procedures again to be repeatable. And so what happened was Pope John the 22nd essentially turned alchemy, a very secretive type of profession, into the modern science of chemistry, in which the chemical processes are really made public. No, there's no secret. And if it's made public, you can have theoretical advancements in any science. So Pope John the 22nd probably could be called as the person who actually made sure that chemistry became a modern science. No longer alchemy, but alchemy became chemistry. And I think we know who William of Ockham is from the previous lectures. But let's look at other clergymen at this time. No, two Catholic priests formalized the scientific method. The first is Robert Grosseteste test. Okay, Grosseteste test, who was a bishop in England and initially came out with the ideas of the scientific method and the theory of the universe expansion. I will show you a video of what he thought about it. So let's play the video.
What is the universe? How was it formed? Why did it come to be? These are questions people have posed throughout history, questions that we are still asking. One remarkable man who considered these questions and then set about trying to answer them was Robert Grossa. Born in about 1170, he was a scholar who would eventually become Bishop of Lincoln until his death in 1253. Although not a scientist in the modern sense of the word, Grossa was keen to ask questions about the world and indeed cosmos around him. As a starting point, Grossa made use of ancient Greek thought, mainly the writings of Aristotle, as well as Arabic and Jewish commentaries on this great philosopher. He tried to develop an explanation of the ancient universe with a reference to a Christian context. Grossa mixture of the four elements. It consists of four subspheres: fire, air, water, and earth. According to Grossa test, water and earth remain mixed together. However, although imperfect and in a different state to those above the sphere, the realm beneath the moon is composed fundamentally of the same material. So, for Grossa test, light is a governing principle throughout the whole medieval cosmos, on Earth as well as in the spheres above. Light fascinated Grossa test. He saw its activity everywhere. Grossa test has sometimes been thought of as the father of modern science, but we cannot be certain that he did carry out experiments. What we can be sure of is that observation and explanation of the natural world were central to his worldview. However, how to reconcile ancient philosophy with the natural world in the Christian medieval context was Grossa test's main task.
Okay, so that's for you the medieval scientific worldview of this Bishop Grossa test. Now, as you can see, he came out with the idea of a Big Bang. Okay. Now, the Big Bang as we know it today. No? But of course, how he framed it is in a much different way as how modern physics and cosmology would frame it. Now, however, he laid down some of the important principles of the scientific method. For instance, this emphasis on observing to explain what nature is. His idea of the universe, as you can see, is a sort of a bridge between more scientific and modern understanding of the cosmos and of the classical Greek and philosophy of science, in which the elements were earth, wind, water, and fire. Okay? And also this idea of spheres, which are actually spheres of perfection, which is actually a Greek idea that the spheres of the universe are perfect. And for Grossa test, those spheres were actually produced by the instantaneous spread of light in the universe. So something of the modern Big Bang and the idea of the universe in the Greek sense are in his worldview. Okay, so let's move on to the next. Sorry about that. Why is it repeating? Okay. Let's move on to the next. Roger Bacon, called the Doctor Mirabilis, or the Wonderful Doctor. He was a don of Oxford University, or a professor there. Now, just like Grossa test, he was fascinated by light. In fact, he attended some of Grossa test's read about Grossa test's writings, no? And he was really fascinated by light. But now he goes one step further. Instead of just speculating about the nature of light, as Grossa test did, he did experiments in optics, therefore putting optics as a modern scientific discipline. Now, of course, how he did that was quite systematic, which we now know as the scientific method. But at that time, in the 14th century, that was known as the method of Father Roger Bacon. So people who were doing the method of Father Roger Bacon were called, they were what we know now as experimental scientists. They were called experimentalists, no? Because they were using the method of Father Roger Bacon. So today, scientists are nothing but people who follow the or practice the method of Father Roger Bacon. Now, the other clergymen later on used the scientific method for physical investigations, like the so-called Merton calculators. Thomas Bradwardine, who became an archbishop, and Richard Swineshead, who became a priest, they were associated with Merton College in Oxford, which even to this day is a very important institution in that university. It still accepts students. Now, one of the things they did was to prove mathematically and experimentally the mean speed theorem, which you probably know from your high school physics, that velocity is 1/2 acceleration times squared. So a uniformly accelerated body travels the same distance as a body with uniform speed, whose speed is half the final velocity of the accelerated body. So by proving this both experimentally and mathematically, Bradwardine and Swineshead founded the science of kinematics, or the systematic study of motion, which is so important in understanding the physical world. Now, of course, the Merton calculators were concerned about measuring time. Okay? And you need a timepiece to do that. So Richard of Wallingford invented the first mechanical clock. Now, who is this priest? Okay, in England. Now, why are clocks so important in the church? Now, for one thing, the Catholic prayers have to be said at the right time. For instance, you cannot have a morning mass celebrated in the afternoon. That doesn't make sense, no? And also, the prayers for the morning are quite different from the prayers that will have to be said in the afternoon or in the evening. You cannot say your morning prayer in the evening. That doesn't make sense, no? Also, this is something very important. No, the clergy have to say more prayers than the lay people, and so they have to say prayers at particular hours, like none at the 9th hour of the day. Now, how would you know that hour if you don't have a clock? And so the Catholic Church was quite particular about that, no? And you need to innovate and invent your own clock. But remember, clocks were not really an old idea. Were not really an idea that was first hatched by the monks and priests of the Middle Ages. The Chinese had their own clocks, no? But they were not mechanical clocks. They were water clocks. And we will know later on when we go to science in China why the clocks in China are quite different from the clocks in Europe, because the idea of time in China, in Chinese culture, is quite different from the idea of time in European culture. However, the clocks that Wallingford made have been reconstructed in England in science museums, and even in the church where he used to preach, where he used to be the priest, no. And this is so important again, because in science you have to document your methods, you have to write up what you did, and that's exactly what Richard of Wallingford did, no? The original clock was destroyed during the Protestant Reformation and all the political and social upheavals that was associated with that historical event. So in the 19th century, people were studying the history of technology and science, were able to reconstruct the clock from the writings of Richard of Wallingford. So if you have a clock, then you can quantify time. Now, mechanical clocks allowed us to exactly measure time, and in doing so, we are able to better understand one important property of the universe, which is the relationship of space and time. And so, example, the common distance measurement that we have is the meter. But what is a meter? A meter is the length of the path traveled by light in a vacuum during a time interval of 1 over 299792458 of a second. So the meter is actually defined as a unit of time. Of course, for practical purposes, we're using meter sticks, no? But the official definition of the meter is like that, no? It's interval of time. Now, if you can relate space and time, then you can see different size objects in one scale. So from the smallest subatomic particle, we can relate that to the size of the galaxy on one scale. And that was only possible if we can relate space and time. That is a major development in the history of science, relating space and time, which other cultures did not really fully understand. But today we take it for granted, no? Clocks and processes. Because of this whole idea of inventing clocks and relating space and time. Now, in medicine, Mondino de Luigi was a doctor, and in the medieval period, he lived from 1270 to 1326. No? He's considered to be the restorer of anatomy. Now, remember that during this time, okay, the Greeks and the Romans did not really allow for the dissection of human bodies. That was contrary to their belief that the human body was sacred. And the early Christian church adopted that kind of tradition. Even in Islam holds to a similar tradition. A Muslim's body cannot be dissected. And under Islamic tradition, even embalming is not allowed. So, a Muslim should be buried within 24 hours of death. And if a Muslim dies, okay, and maybe the doctor wants to do an autopsy, that's not allowed because the family will never give consent because it's against Muslim belief. Even I think the Jews are still adopt a similar idea or belief, no? But how could somebody in the Middle Ages dissect people when the early Christian church did not really look with favor on the idea of dissecting human beings? Remember that in Greece and in Rome, the only reason why the doctors were able to know some anatomy is because they were dissecting monkeys and other animals that have a similar anatomy to people. But remember, that's not objective because the anatomy of a monkey, while it's very similar to the anatomy of a human being, is not really the anatomy of a human being. So, by this time, it was already felt that in order to make sure that we know an accurate understanding of medicine in the human body, we need to dissect people. So how did Mondino de Luigi dissect his people? No? Well, at that time, you can only dissect convicted criminals. Because if you're a criminal, you no longer belong to society. Okay? In other words, it's as if you're no longer considered a human being. And chances are, if you were a criminal, you were excommunicated from the church, so you are not Christian. Of course, today, our understanding of human dignity and human rights as much evolved than that, no? For example, you cannot just dissect any dead body of a person without the consent of the family. And perhaps you and I, if we're really very generous, when we kick the bucket, we can probably donate our bodies to the College of Medicine. But of course, that is in our will, okay? And it's a purely voluntary thing to do. But before, you cannot do that. You have to be a criminal to be dissected. Anyway, Mondino de Luigi was a professor of medicine in Bologna, in Italy, the oldest university in Europe, okay? And the oldest medical school in Europe. Now, one of the big questions now is science and religion really in conflict? If the church allowed science to develop, why then there is a popular view that science and religion are in conflict? Now, this probably dates back to the Renaissance and Reformation. During the Renaissance, okay, and the Reformation, a huge part of Christian Europe decided to become Protestant and left the Catholic Church. And so the Catholic Church went into a crisis and had to react appropriately. Okay? The Protestants, however, emphasized the Bible, while the Catholics would emphasize Catholic tradition. And the Catholic Church reformed itself in the Council of Trent and promotes more rigorous academic scholarship that is peer-reviewed. At the same time, the Catholic Church promoted the arts. Okay? While the Protestants, they agreed to have the Bible to be published in the vernacular, because the Bible then was published in Latin and only the scholar, the educated, would be able to read it. And because it was published in the vernacular, this allowed a political environment for science to advance, because a lot of people are able to read the Bible in their own language and have their own understanding of it. Now, it's important to note that the influence of the Bible in the vernacular languages was greatest in human society at around the time of the scientific revolution. Now, why is this so? Okay, but before we get into that, the Catholics emphasized tradition. And Catholic tradition allowed for the depiction of the human form in art, especially the human form of the holy people, the saints, and of course, Jesus Christ. The most famous of those works at this time is Michelangelo's Last Judgment, which is in the Sistine Chapel of the Vatican. Now, if you look at the painting here, this is a major break from the medieval view of holy people. For instance, and this is actually drawing from an older tradition in Greece and Rome. Jesus here is depicted as if he was like the sun god Apollo, and all of the apostles and the saints are depicted in the nude. Except the Virgin Mary. Perhaps Michelangelo wouldn't go that far to depict the Virgin Mary in the nude. Now, why is this so? For one thing, there was already a much interest in depicting the human anatomy as objectively as possible. The more realistic, the better. That was a result of advances in understanding medicine. That's one of the things. So this tradition in the Renaissance, actually depicting people in the nude, took off because of one of the reasons, because of the increasing understanding of the human body as it really is. Now, the Protestants emphasize the printing of the Bible in the vernacular languages, and this is the Gutenberg Bible, as you would see. Now, if you can print the Bible in the different languages, like English, therefore, you can print it. You can also print science books in the different languages. So, the most important books of the period is the work of Copernicus, the De Revolutionibus, in which he proposed the heliocentric hypothesis, the Dialogue of Galileo, and the Principia of Newton. Now, the Book of Copernicus and the Book of Newton was published in Latin, which is the scholarly language of the time. But if you look at Galileo's Dialogo, that was written in Italian, and Galileo took the conscious decision not to write it in Latin, but to write it in Italian, so more people can read it. So this is one of the first science books that had a wide readership in Italy. Eventually, it was translated into other European languages like Spanish and even German. So spreading the whole idea of the message of the of the validity of the heliocentric hypothesis. Of course, we know what happened to Galileo. Okay, one of the criticisms of his work is that there was no experimental demonstration of his hypothesis, no? Because he did not have the tools to do that. He did not have the mathematical tools to do that. That would come with Newton. Anyway, I think you've seen this picture, Copernicus in art, okay? As if receiving a divine revelation about the truth and the factuality of the heliocentric hypothesis. Now, anyway, let's now move on to the so-called last scientific medievals. There are about 7 of them. Copernicus, Brahe, Kepler, Vesalius, Galileo, Steno, and Newton. Some of them may be familiar to you. Now, take a look at the list. Okay, there are only 2 priests. Copernicus was with the clergy of the Catholic clergy, and Steno was a Catholic bishop. No? Kepler studied for the Lutheran ministry, but did not continue. Okay, so Kepler started to train for being a pastor of the Lutheran Church, but he did not continue. No? And also, not all of them were, while in the medieval period, all of them were Catholic. In this case, they were not all Catholic. Tycho Brahe was Protestant. Kepler was Protestant. Remember, he was training for the Lutheran ministry. Vesalius was Protestant, and Newton was Protestant. The only Catholics here are Steno, Galileo, and Copernicus. Now, Copernicus was a mathematician and a member of the clergy as a canon of the cathedral, one of the priests who actually managed the cathedral affairs. And he proposed the heliocentric theory and used geometry to prove the heliocentric theory, in which we see here, okay, this is the geocentric hypothesis, and this is the heliocentric hypothesis. Now, both can be represented mathematically. The question is, which among them is the simpler to represent mathematically? And so it's the heliocentric hypothesis that is more mathematically simple to represent. In fact, I have a friend from the Ateneo who did a doctoral dissertation on this. No, he used a kind of algebra called Clifford algebra to describe the mathematics of the geocentric hypothesis and the heliocentric hypothesis. Okay, he told me that the geocentric hypothesis is correct if you use that kind of mathematical system, no? And also the heliocentric theory is correct under the same mathematical algebraic system. But the important point here is which among them is more simple in explaining the motions of the planets, and which among the two have more correspondence with nature. Obviously, he told me that the heliocentric hypothesis is likely the factual one, because this is more it's more simple, really, and has more correspondence with nature. Now, Tycho Brahe used the data from Copernicus also, okay, and he was also the last astronomer to observe the heavens without a telescope, and he proved that changes can happen in the universe. The planets could change, the stars could explode. He was able to observe a supernova, okay, and he accurately observed the movement of the planets. And that data was used by Kepler later on. But because Kepler worked with him for a while, no? But Tycho observed it in Uraniborg in Denmark, his observatory, and came up with his own explanation of how the planets move around the sun. While the planets could move around the sun, okay, the planets were moving around the sun, but the sun was moving around the earth. Obviously, this was not really a very simple system to explain. So, for historical interest, we know that there was a third system to describe the solar system. But of course, it's the heliocentric theory that's more simple. Okay, so Kepler was the one who essentially used the data of Tycho, which is actually very accurate. So he came out with a better explanation of how the planets orbit around the sun, and the planets orbit around the sun in an ellipse, in an elliptical shape. Now, in medicine, Andreas Vesalius again dissected people. Again, they were convicted criminals. And he came up even with more accurate drawings of the anatomy, even more accurate than what Mondino de Luizzi came out with. And he came out with anatomical studies which are so accurate that even medical students, even to this day, can use it. And if you look at the picture on the right, because you can only dissect criminals, the criminals were still hanging from the gallows, and he dissected it and drew about them. Galileo, on the other hand, is the first modern experimental scientist because he insisted on doing experiments, not just speculation. And he's the first one to observe or to use the telescope in a scientific investigation. And he came up with two new important sciences, statics and mechanics, based on the previous work on motion, on the physics of motion. Now, of course, we know Galileo as the one who insisted that the heliocentric theory was right. In fact, it is right, but the problem is he did not have enough data to prove it conclusively. Now, one of the important things to note in this so-called Galileo affair was the church at that time was being threatened by the Protestant Reformation. The authority of the church was threatened. Obviously, if that's the case, then they would react in a bad way to anything that's perceived to challenge their authority. Also, the important thing to remember is Galileo, okay, the church, the cardinals of the church, especially Robert Bellarmine, they were not really people that were not trained in the sciences. Remember that the priests have to study the sciences. And so, what Bellarmine wanted is for Galileo to come up with really demonstrable experimental evidence, which he did not have at that time. No? In fact, he tried to justify it by using other analogies, okay? Like the movement of the tides. But that definitely, the tides couldn't prove that the earth is moving around the sun. Because the tides, as we know it, is really due to the gravitational attraction between the sun and the moon and the earth and the sun. No, it doesn't directly prove that the earth is moving around the sun, in which Galileo wanted to prove. Now, all of those experimental proofs would come in much later, in the time of Newton. So anyway, Galileo, because also personal pride and other things, no, and of course the theologians were also at fault because they were misconstruing what science could explain and what religion can explain and confusing the two. And so what happened is Galileo was suspected of heresy. But how can you be heretical or be violative of the church teaching if you're just explaining the natural world? It will take until 1992 for Pope John Paul II to apologize for the mistakes of the church in the Galileo affair. So Galileo was suspected of heresy and was put into house arrest. And he said, whatever the church says, the planets still move. E pur si muove, which is the battle cry now if there's political or religious interference in science. For example, in our country, the Congress is not really thrilled with some of the epidemiological prediction of our academics, and they want to shut those academics up. So whatever, even if they succeed in doing that, science will still move. That's the important point there. So anyway, let's look at this. What is this? This is the law of universal gravitation in vector form, which explains and gives the evidence for the theories and hypotheses of Galileo. It will take Newton to explain that. So Newton is considered to be the last medieval scientist. Why is that so? Because aside from having works in mathematics,
and everywhere spies
right?
passed out.
Aside from having works in mathematics,
We track a party of Urukai westward across the planet.
he wrote books on religion and also on alchemy. But we know him best for the calculus and the laws of motion and gravitation, which are in the Principia. Okay? His famous book, which was written in Latin. Okay? Now, Nicholas Steno was a priest and is a saint of the Catholic Church. Is now called the father of geology because he came up with the theory that the oldest layers of rock are older than the layers of rock that are at the bottom of any stratum are older than the layers of rock that are above and closer to the surface. This is what we call the law of superposition. Okay? He is famous to having said that science can only advance by research. So science can only advance by research. That's what Steno said during that time. No? Now, Steno did not become a saint because of his science, because he was really a good and pastoral priest. But he was also a scientist. That's the important point there. No. Now, what is the origin of science in our country, in the Philippines? No. The modern science was first taught here by the UST. When the UST was established in 1611, it was already teaching the sciences from anthropology to meteorology. They were teaching it. Of course, their students were people who were preparing for the priesthood. Now, UST is a modern university. Even at the time it was founded, for the simple reason that the medieval period ended more than a century before UST was founded, and the Renaissance started about a century before UST was founded. So when UST was established here, it was already a modern university, really. Now, and it was teaching not just the theological faculties, it was teaching law, it was teaching the humanities, and of course, science. Now, the first scientist in the Philippines who did work is actually Joseph Camel, who was a Jesuit brother, and he was studying the biodiversity of the Philippines, especially plants. And he is credited to have come up with the first work of science about the Philippines, the Herbarium Philippinarum, which is the catalog of plant biodiversity in this country. Now, Camel was a modern scientist because his science is science. While he did work for the church, for the ministry of the church, okay, when he did science, it was actually for the cause of science, really. Okay, just like Steno. Steno was doing science, but it was not really, they understood science in a very modern sense. Now, you don't use science to understand God, okay? Unlike in the medieval period, no? You use science to understand nature. while you use your theological training and religion to understand the nature of God. So that is the really part of the modern world, no? Now, what is modern science? No, it explains nature, and Pope Sylvester was one of the first people to expound on that. It's empirical. All the medieval scientists actually accepted that principle. It's premised on objectivity. Thomas Aquinas was one of them, okay, who first proposed the concept. It's an organized body of knowledge, and all the medievals actually accepted that idea. It explains nature by using a mathematical model. Okay, let's go back to the Merton calculators who modeled the physical laws of physical motion mathematically. And medieval science always placed God as a part of understanding nature. But modern science is no longer that, no? You cannot say God is not in the equation. The medievals did not really accept that principle. But now, in modern science, we accept it. And it was Charles Darwin who really ended this whole idea that you can know God by doing science, no? Because the origin of life in the human species is actually one of the most controversial things that happened, no? And also, okay, while that is controversial, no, because we know the religious tradition said that man was created by God, no. But Darwin said that you don't need that to explain that because you just need natural law principles to explain the origin of biodiversity. So now God is no longer part of the understanding nature, no? No longer part of the equation to understand nature. This is a picture of a slide depicting the tree of life, which is a statistical model of the evolution of life on Earth. Of course, this is expressed in a graphical way with pictures of a frog and a butterfly just to make it more understandable. But there's a single-celled organism at the bottom of the tree of life, no, which gave rise to biodiversity through evolution by natural selection. In the theory of evolution, Darwin proved that science is not a way to understanding God, but just to understand nature. So, anybody with a religious tradition would probably not agree that your God is a single-celled organism. So today, when we do science, it's just to understand nature, and that's it. Okay? We do not use science as an article of our religious belief. Okay? We don't do that anymore, no? It's just to understand nature. So what is the legacy of all this medieval science, no? The important point here is science is built on previous theories, which can even arise from a religious tradition or a religious culture in which a culture is dominantly religious. For example, the golden age of science in Islam, it was a culture that was Islamic, okay, and gave rise to science, which was borrowed by Catholic Europe, in which the church was a dominant cultural and political influence, and yet science developed. And some of the practitioners of science were Catholic priests, and a few of them were popes, and some of them were saints. Okay? This is a very important point here, no? Science came out of a cultural milieu, but that cultural milieu required autonomy and freedom of research. And in Europe, it was the academic freedom of the universities that guaranteed a lot of that. Okay, so that is the legacy of medieval science. If I have seen a little further than it is by standing on the shoulder of giants that was attributed to Newton, but actually it's from Bernard of Chartres, a priest that was inspired by the works of Pope Sylvester the Second, who was the first of the scientist popes. So, since then, I think we have the second one that we know is really trained in sciences is the present Pope Francis, no? But probably John the 22nd was also could be considered as a scientist because he was trained in alchemy. But alchemy wasn't really the science of chemistry as we know it now, no? Pope Francis trained as a chemical technologist before he decided to go into a priesthood. So it's not surprising that he has very strong views for science and technology. Okay, so that is medieval science. Next time we'll go to the history of science in China.